All right, back to our polynomials. So we're going to start talking about factoring, and the very first type of factoring we're going to do is greatest common factor. So when you begin factoring, no matter what kind of polynomial you're given, you're always going to try and do the greatest common factor first. So I'm going to jump down and do a few examples. You can put this in your notebook, and then it might be a good idea to add one of those examples up here, just so you can have that to refer to later. All right, so let's take a look here. So when I talk about greatest common factor, you probably did this back in grade school when you were just looking at numbers. Factors are any numbers that multiply up to the given number. So for example, with the number 10 that we have here, 10 is made up of 5 times 2 and 10 times 1. So 1, 2, 5, and 10, those are considered factors of 10. So if I think about this, oh, that's not what I want to do. Sorry. If I think about these two values here, 10x squared and 5x, I want to figure out what they have in common. And I'm looking for the greatest common factor. I need to get my button straight here. Greatest common factor. So I want the biggest number and the most variables that go into each. So between 10 and 5, in my head I'm thinking, what's the largest number that divides evenly into my two numbers? So what's the largest number that will divide into, into 10 and 5, or whatever two numbers you happen to be dealing with? Well, I know that 10 is 1, 2, 5, and 10. Those are all the things that multiply to 10. And 5 is 1 and 5. Well, if I look between these, the common factors are 1 and 5. They both have those. But the greatest one is 5. So 5 would be part of my greatest common factor. And then if I have x squared, well, that is really x times x. And on the right-hand side, I just have 5x, which is just a single x. Well, the greatest common factor that they would share is just one of the x's. So 5x is my greatest common factor between those two. So that's how you would find the greatest common factor. Let's see if we can use that to actually factor something out. And when we're factoring, we're going to be able to use this to eventually find the x-intercepts or the zeros of our quadratic functions. So let's look here. We have 6 and 8, and then we'll deal with the x's after. So 6 and 8. I know that 6 is built up of 1, 2, 3, and 6, and 8 is 1, 2, 4, and 8. Well, the greatest common factor I see is 2. That's the only one. There's only 2 and 1 that they have in common, and 2 is the largest. So 2 is going to be part of my greatest common factor. For the x's, the first term has 4 x's. The second term has 2. So the first one has 4, the second one has 2. Well, look, they have 2 in common. So x to the second is my greatest common factor. To factor it, we need to make up the original problem. So we're reversing the distributive property that we did in the beginning. So I'm going to put parentheses because it's a multiplication here. And then I'm thinking, okay, well, my first term, 6x to the fourth, divided by 2x squared, what's left is going to go in the parentheses. Well, 6 divided by 2 would leave me with 3. X to the fourth divided by x squared would leave me with x squared. We subtract our exponents when we divide. I'm going to do the same thing over here. Negative 8 divided by positive 2 is negative 4. X squared divided by x squared, those would cancel out. So I just have 2x squared times 3x minus 4. You can always check to see if you're right by distributing 2x squared back into the equation. We would get 6x to the 4th minus 8x squared. Well, as long as that's the same as our original problem, we were right. You don't have to do the distributing because we want our end result to be this factored form, but it can use it as a check to see if we did it right. The next two things I'm giving you are two terms, are x and a positive 3. So the number in front of x would be a 1. Well, the most these two have in common is just a 1. 1 and 3, the only common factor is 1. And there's an x in the first term, but not in the second term. So 1 is the most I could take out, and I'd still be left with x plus 3. When you can only take out 1, so the factors are 1 and itself, then we're going to call this polynomial prime, meaning the only factors are 1 and itself. Just like a prime number, 2 or 5, the only thing that goes into it is 1 and itself. All right, let's get a little more complex here. So I'm starting with my numbers. I take it one piece at a time. So 4 and 10, negative 10, I'm actually going to add another piece onto this, just so we get to see all three, plus 6x to the second, let's say. So if you have 3 terms, you can only take the greatest common factor out of all the terms. So I have to look at 4, 10, and 6. The largest number that goes into all 3 of those is 2. So that's what I'm going to begin with. So 2 is my greatest, starting my greatest common factor. Next, I'm going to go to the x values. So I have x to the first here, I have x to the third here, and x to the second here. Well, this first term has 1 x to give up, this one has 3, and this one has 2. I can only take out what they have in common. The most they have in common is 1. So x to the first is going to be part of my greatest common factor. Next, I'm going to look at the y's. Here I have 2 to give, here I have 3, but here we don't have any. So if this third term doesn't have a y, it's not something they all have in common. So it cannot be part of the greatest common factor. So I'm going to begin my parentheses there, and then what goes inside should still have 3 terms. And I'm going to get that by dividing each one by the greatest common factor. So 4xy squared divided by 2x. Well, 4 divided by 2 is 2. X divided by x would cancel, and then the y squared would still be there. Negative 10x cubed y cubed divided by 2x. Negative 10 divided by 2 is negative 5. X cubed divided by x is x squared. And then the y cubed is going to remain because nothing is being divided. No y's are being divided. Lastly, 6 divided by 2 would give me 3. X squared divided by x would leave me with x. So that would be my factored polynomial. All right, and one last one here. Here it's set up a little bit differently, but I'm still looking for the greatest common factor. Let me see if I can move this down a little bit. There we go. So when I look at this, these two terms, the first one is 4 times 3x minus 1, and the second one is 6y times 3x minus 1. Each one of these things is a term because they're stuck together with multiplication. So what I see they have in common is 3x minus 1. So I can take out 3x minus 1 as the greatest common factor. And then if I take my first term and divide it by 3x minus 1, that's going to cancel away. If I divide this side by 3x minus 1, also going to cancel away. So all I'm left with is 4 from the first term. If we pluck out that 3x minus 1, I'm left with a 4. If we pluck it out of the second term, I'm just left with 6y. So it's just another version of factoring with the greatest common factor. So go ahead and finish up your problem.